Hi students, myself Kale SL, Rayat Shikshan Sanstha's RBNB College Rampur. In the previous video lecture, we have completed indefinite integration and we have taken 25 lectures for indefinite integration. We are now going to start next topic number 4, definite integration. Here we start definite integration mathematics part 2, new syllabus, class 12th and lecture number 1st. Now see here, definite integration is divided into 3 parts. Definite integration. Here definite integral as a limit of sum, then here fundamental theorem of integral calculus, fundamental theorem of integral calculus, and third part, evaluation of definite integral using properties. So this definite integration contain definite integral as a limit of sum, fundamental theorem of integral calculus, and evaluation of definite integrals using the properties. Now this definite integral as a limit of sum is deleted to batch 2020. So we will see only fundamental theorem of integral calculus and evaluation of definite integral using properties. There are 2 exercises, 4.1 and 4.2, but 4.1 is deleted, so we are going to start only exercise 4.2, which depends on fundamental theorem of integral calculus and evaluation of definite integral using properties. In exercise 4.2, there are 3 questions, question first, question second and question third. Every question contains 15 problems. Question first and question second depends on fundamental theorem of integral calculus, and all examples are solved in indefinite integral, that is in the previous chapter. We have seen all examples in the previous chapter. This definite integration is nothing but the Xerox copy of indefinite integration. We have solved all problems. Only here different part is evaluation of definite integral using properties, and properties is nothing but the modified formula. So all problems we have learned in the previous chapter. There is here revision only. Now see here, we see fundamental theorem of integral calculus. Let y is equal to f of x. Let y is equal to f of x be a continuous function. Defined on closed interval ab, and integration of f of x dx, that is this integration is indefinite integration. Integration of f of x dx is equal to g of x and plus c here constant of integration. We assume this integration of f of x as a g of x, we assume. Now here then integration of f of x dx, we have take it as g of x plus c. Now here we take a and here we write b. This a is the lower limit. Integration from a to b f of x dx, and solution of this integration is g of x plus c. So we have to take this a and b on the right hand side also. We take here square bracket like this and put here a and here b. These are the values of these a and b are the values of variable x. A is called the lower limit and b is called upper limit. Means we take this indefinite integration as usual using the previous methods, and solution is this, and in the solution we put only the value of x as b and value of x as a. Now how to put these values? So this is equal to g of, in place of x we put b, that is g of b and plus c as it is. Now we put the value of x as a, so it is g of x as a and this plus c. So here in place of x we put upper limit, that is g of b plus c, and then after completing this step, putting the values of b, now we have to put the value of x as a, so g of a plus c, and take here minus sign. Get it? And therefore we get here g of b plus c multiply by minus sign, so it is minus g of a and minus plus minus c. This minus c and plus c get cancelled, and therefore we get g of b minus g of a. Get it? Now here integration of f of x dx is g of x plus c. While we take definite integration from a to b, definite integration from a to b f of x dx, then solution is g of x, so we take g of upper limit b minus g of lower limit a, and don't take this constant of integration, indefinite integration, because it is cancelled due to this upper limit and lower limit. So this is the basic definition of definite integral integration from a to b f of x dx, that is equal to g of b minus g of a. What is its geometrical meaning? Indefinite integration and definite integration. Suppose this is function y is equal to f of x is function, and we want to find here integration from f of x dx, integration of f of x dx. This integration of f of x dx is nothing but the area under the curve y is equal to f of x. We take the small part of this area and we add these areas by this integration. This is the integration of f of x dx. Now here integration from a to b f of x dx means it is the definite fixed value of that area. Suppose here x is equal to a, here suppose x is equal to a, and here suppose x is equal to b. Then we take the area of the line x is equal to b, and under the curve this y is equal to f of x. Means we take the area of f of x below this curve, and this area is bounded by the line, this x is equal to a, x is equal to b, and above this x axis. This is the geometrical meaning. Means this area we take the sum of these small parts from a to b. This is definite, this is fixed value. So this is the geometrical meaning of integration from a to b f of x dx. Now here we start exercise 4.2 and question number first. In question number first I told there are 15 problems. We will see one by one. So question first is evaluate. Question first, evaluate first problem, integration from 1 to 9 integration from 1 to 9 x plus 1 upon under root of x dx. Now call this integration as I is equal to integration from 1 to 9 x plus 1 divided by root x dx. Now we have to take the integration of this rational function using previous methods. So here this is equal to integration from 1 to 9. We write this as x plus 1 upon this root x as x to the power 1/2 dx. Now divide separately numerator. So we get integration from 1 to 9 x upon x to the power 1/2 plus 1 upon this x to the power 1/2 dx. Now take separate integration. So I is equal to integration from 1 to 9 x upon x to the power 1/2. It becomes x to the power 1 minus 1/2. 1 minus 1/2 dx plus integration 1 upon x to the power half. It becomes x to the power minus 1/2 dx. And now use here. So we write this as x to the power 1 minus 1/2. 1 minus half, that is equal to half. Integration 1 to 9 x to the power half dx plus integration 1 to 9. Here also write 1 to 9 x to the power minus 1/2 dx. And now take here integration of x to the power n dx. Use formula integration of x to the power n dx, that is equal to x to the power n plus 1 upon n plus 1 plus constant of integration. Now here, so it is equal to x to the power 1/2 plus 1, that is equal to 3/2 upon 3/2 same number, and write square like this, and write here 1 lower limit 1 and here 9 upper limit 9 plus here integration of x to the power minus 1/2, that is minus 1/2 plus 1 means 1 minus 1/2. So it is x to the power 1/2 divided by 1/2, and it is from 1 to 9. Get it? Now here this 3/2 or here 1/2, we cannot we have to not put the value in this. These are the constant, so take outside the this square bracket. We write here 1 upon 3/2. Here it is 1 upon 3/2. It becomes 2 upon 3/2. 2/3. And x to the power 3 upon 2, 1 to 9. Plus here also 1/2 become 2 upon 1, that is 2. And x to the power 1/2, 1 to 9. So it is equal to 2/3 in bracket. Here put the value of x as 9. Firstly put upper value 9. So 9 to the power 3/2. 9 to the power 3/2. Then put lower value x as 1. So 1 to the power 3/2. And here take sign minus. Plus here 2 as it is. 2 in the bracket. Here put the value of x as 9. So 9 to the power 1/2. Middle sign is minus. Then put x as 1. So 1 to the power 1/2. And solve this. So this is equal to 2 upon 3. Now here 9 to the power 3/2. 9 to the power 3/2 we write like this. 9 to the power 3/2 is equal to 9 to the power 1/2 to the power 3. And 9 to the power 1/2 means square root of 9, that is 3. So 3 to the power 3. 3 to the power 3. 3 into 3 into 3. 3 3s are 9. 9 3s are 27. So it is 27. So here we write 27 minus 1 to the power anything, that is equal to 1. Then here plus 2 and 9 to the power 1/2 means square root of 9. It is 3 minus 1 to the power anything, that is 1. So this required integral I becomes I is equal to 27 minus 1, that is 26. 2/3 into 26. Get it? Here 2/3. 27 minus 1, that is 26. Here 2. 3 minus 1, that is 2. So plus 2 into 2. So here 26 2s are 52. So 52 upon 3 plus 2 2s are 4. So this is equal to 52 plus 3 4s are 12 divided by 3. It is equal to 2 plus 2, that is 4, and 5 plus 1 6. So 64 upon 3. This is the solution. So this is the fixed value. This is the fixed value, that is 64 upon 3. Take the screenshot. So in this way we completed here first problem. Now second problem here, integration from 2 to 3. Integration from 2 to 3, 1 upon x square plus 5x plus 6. 1 upon x square plus 5x plus 6 dx. Now we have to identify this problem. This problem is of the type 1 upon ax square plus bx plus c, and we know how to solve it. Firstly, we make the coefficient of x square as 1, then we complete the square, and then we use standard formula. So here firstly call this as I. Let I is equal to integration from 2 to 3, 1 upon x square plus 5x plus 6 dx. Now observe here the coefficient of x square is 1, so directly complete the square. So this is equal to integration 2 to 3, 1 upon, we write this x square as it is plus 5x as it is and plus 6 here, and we have to add here third term. How we calculate that third term? Take 1 half into coefficient of x bracket square. 1 half into coefficient of x. Coefficient of x is here 5. So 1 half into 5 and bracket square. So 1 into 5, that is 5 upon 2 bracket square. So 5 square, that is 25. 25 upon 4. So we have to add here 25 upon 4. So here we add 25 divided by 4, and we have to cancel this. So minus 25 by 4 and dx. So this is equal to integration from 2 to 3, 1 upon this x square plus 5x plus 25 upon 4. It is the complete square of square root of x square is x, middle sign plus, so plus, and square root of 25 by 4, it is 5 upon 2 and bracket square. Now here plus 6 4s are 24, and 24 minus 25, that is minus 1. So minus 1 upon 4. Minus 1 upon 4, we write it as 1 upon 2 bracket square. See again here, 6 into 4 plus 24 minus 25. So it is minus, so we take here minus sign. Minus 1 by 4, and we write that 1 by 4 as 1 upon 2 bracket square. And now here use the formula, integration of 1 upon x square minus a square dx. That is equal to 1 upon 2a log of x minus a upon x plus a plus constant of integration. So this required integral I becomes I is equal to 1 upon 2 into a. A is here 1 half. A is here 1 half into log of x. X means this bracket, x plus 5 upon 2 minus a means 1 half, divided by x plus a, that is x plus 5 by 2 plus a means 1 half. This is the solution. And here integration from 2 to 3. So we take square bracket like this and write here 2 and here 3. Which formula we use here? Integration 1 upon x square minus a square dx, that is equal to 1 upon 2a log of x minus a upon x plus a plus constant of integration. Integration 1 upon x square minus a square, or 1 upon a square minus x square, or 1 upon x square plus a square. These are the three formulas. So out of that we use this formula. And so here x is x plus 5 by 2 and a is here 1/2. So x minus a upon x plus a. This 2 and 2 get cancelled. So we get I is equal to 1 into this. So log of, we multiply by, or here 5 by 2 minus 1/2. Denominator is same. So take here subtraction, 5 minus 1. 5 minus 1, that is 4. 4 upon 2, it is 2. So x plus 2 divided by, here x as it is, here also denominator same. So add the numerators, 5 plus 1, that is 6 upon 2, it is 3. And from 2 to 3. Now put the value of x as a 3 and then x as a 2. So I is equal to here log of, in place of x we put 3. So 3 plus 2 divided by 3 plus 3 minus, now put the value of x as 2, minus here log of 2 plus 2, x is 2. So 2 plus 2 divided by 2 plus 3, 2 plus 3. And so I is equal to log of, here 3 plus 2, that is 5 upon 6 minus log of 4 upon 5. Now take here log common. So I is equal to log of this 5 by 6 upon this 4 by 5, upon this 4 by 5. When we take log common and there is a subtraction, so here this divided by this. So we get here I is equal to, or this is equal to log of this 5 by 6 as it is into, we take 4 by 5 as 5 upon 4. Get it? And therefore final solution I is equal to log of 5 5s are 25 and 6 4s are 24. So 25 upon 24, log of 25 upon 24. 5 5s are 25 and 6 4s are 24. So this is the final solution. We highlight this solution and take the screenshot. Now here we see third problem. Third problem, integration from pi by 4 to pi by 2. Integration from pi by 4 to pi by 2, quad square x dx. Quad square x dx. Now consider this as I. So I is equal to integration from pi by 4 to pi by 2 quad square x dx. So when there is a trigonometric function, use its formula. We know that quad square x is equal to cosec square x minus 1. We know the third fundamental identity. 1 plus quad square theta is equal to, what is third fundamental identity? 1 plus quad square theta is equal to cosec square theta. And therefore we get cot square theta as a cosec square theta minus 1. And therefore this is equal to integration from pi by 4 to pi by 2. We write here cosec square x minus 1 dx. Now separate the integration. So this is equal to integration from pi by 4 to pi by 2 cosec square x dx minus integration 1 dx from pi by 4 to pi by 2. Now integration of cosec square. Cosec square is the derivative of cot x. d by dx of cot x is equal to minus cosec square x. And therefore integration of cosec square x is I is equal to cot x. But answer start with c. So take here minus I. So minus cot of x. And integration from pi by 4 to pi by 2. So we write here pi by 4 to pi by 2. And then here in minus integration of 1 dx, that is x. So x from pi by 4 to pi by 2. So it is equal to minus cot of, in place of x we write pi by 2, so pi by 2, and then minus cot of, in place of x we write here pi by 4. Again here minus, in place of x we put pi by 2, so pi by 2, minus in place of x we put here pi by 4. Now here cot of pi by 2 minus cot of pi by 2 is 0, cot 90 it is 0, tan 90 is not defined but cot 90 is 0, minus cot of 45 it is 1, tan of 45 is 1, so cot of 45 also 1, minus here pi by 2 minus pi by 4, we know that pi by 2 is 90, pi by 4 is 45, 90 minus 45 that is equal to 45, so that is pi by 4. Now here it is equal to minus and minus become plus, so 1 minus pi by 4 is the solution. So I is equal to 1 minus pi by 4, this is the final solution. Take the screenshot. Now here fourth problem, integration from minus pi by 4 to pi by 4. Fourth problem here, integration from minus pi by 4 to pi by 4, minus pi by 4 to pi by 4, 1 upon 1 minus sin x dx, 1 upon 1 minus sin x dx. Firstly call this as I. So let I is equal to integration from minus pi by 4 to pi by 4, 1 upon 1 minus sin x dx. Now here we take the conjugate of denominator and multiply to numerator and denominator. What is the conjugate of denominator? Here 1 minus sin x, so we take 1 plus sin x and multiply to numerator and denominator. So it is equal to integration from minus pi by 4 to pi by 4, 1 upon 1 minus sin x as it is, and into 1 plus sin x divided by 1 plus sin x dx. So this is equal to integration from minus pi by 4 to pi by 4, 1 into 1 plus sin x, that is 1 plus sin x, and here in the denominator 1 minus sin x into 1 plus sin x, that is a minus b into a plus b. Use the formula a square minus b square. So a is here 1, so 1 square, that is 1, minus b is here sin x, so b square, that is sin square x, sin square x dx. And therefore I is equal to this required integral I, that is equal to integration from minus pi by 4 to pi by 4. Here 1 plus sin x, 1 plus sin x numerator as it is divided by this 1 minus sin square x. Using the first fundamental identity we put cos square x. So it is cos square x, because first fundamental identity is sin square x plus cos square x is equal to 1, and so we get here 1 minus sin square x is equal to cos square x. Now take the separate division. So it is equal to integration from minus pi by 4 to pi by 4, 1 upon cos square x, 1 upon cos square x plus sin x upon cos square x, we write cos x into cos x, and dx. So this is equal to integration from minus pi by 4 to pi by 4, and this 1 upon cos square x is sec square x, plus this 1 upon cos x is sec x, and sin x upon cos x is tan x dx. Now take the separate integration, and so it is equal to integration from minus pi by 4 to pi by 4, sec square x dx, and plus integration from minus pi by 4 to pi by 4, sec x tan x dx. And we know that both are the derivatives. This is also derivative of tan x. Sec x tan x is derivative of sec x. So these are the standard formulas. So we use here I is equal to I is equal to integration of sec square x dx, that is equal to tan x, and it is from minus pi by 4 to pi by 4, minus pi by 4 to pi by 4, plus here plus integration of sec x tan x is sec x, and it is also from minus pi by 4 to pi by 4. And now put the value of x as pi by 4 and then minus pi by 4, and therefore I is equal to here tan of, in place of x we put upper value pi by 4 minus tan of, in place of x now we put minus pi by 4, it is minus pi by 4, then plus here sec of x as a pi by 4, sec of pi by 4 minus sec of minus pi by 4. Get it? So this is equal to, we know that tan of pi by 4 it is 1, but write firstly as it is tan of pi by 4, and this minus and minus become plus. This tan of minus theta, we know that tan of minus theta is minus tan theta, so minus and minus become plus, it is tan of pi by 4. Now here plus this sec of pi by 4 as it is, and we know that sec of minus theta, it is sec theta, sec of minus theta is sec theta, so it is minus sec of pi by 4. See here, tan of minus theta is minus tan theta, here minus minus become plus, and here sec of minus theta is sec theta, cos of minus theta is cos theta, sec of minus theta is sec theta, cos of minus theta is cos theta, sec of minus theta is sec theta, and so here it is sec of pi by 4. This minus sec of pi by 4 and plus sec of pi by 4 get cancelled, and now here tan of pi by 4 plus tan of pi by 4, it is equal to 2 times tan of pi by 4. Get it? And tan of pi by 4, that is tan 45 degree, it is 1. So here it is 2 into 1, and 2 into 1 it is 2, so I is equal to 2. This is the final solution. Take the screenshot. Now here we see the fifth problem. Fifth problem, integration 3 to 5, 1 upon under root of 2x plus 3, 1 upon under root of 2x plus 3, here minus, and under root of 2x minus 3 dx. So here in the denominator there are two roots and subtraction sign. So to solve such type of problems we rationalize the denominator. Firstly call this as I. So I is equal to integration from 3 to 5, 1 upon under root of 2x plus 3 minus under root of 2x minus 3 dx. Take rationalization. So integration from 3 to 5, this rational function as it is, that is 1 upon under root of 2x plus 3 minus 2x minus 3. Only we take here, instead of minus sign, plus sign, and multiply to numerator and denominator. So it is 2x plus 3 and plus 2x minus 3 divided by 2x plus 3 and plus 2x minus 3, and right here dx, here into. Now take the multiplication of both the numerators and both the denominators. In numerator here 1 into this numerator, that is this denominator. So this is equal to integration from 3 to 5 under root of 2x plus 3 plus 2x minus 3 under root of 2x minus 3 divided by here root of 2x plus 3, here also root of 2x plus 3, here root of 2x minus 3, root of 2x minus 3, only here minus sign and plus sign. So we call this as a and this as b. So a minus b into a plus b, that is equal to a square minus b square. So root of 2x plus 3 square minus root of 2x minus 3 square dx. So this is equal to integration from 3 to 5 under root of 2x plus 3 plus under root of 2x minus 3 divided by this root sign and square get cancelled to each other. So here 2x plus 3. 2x plus 3. This root and square also get cancelled. Here 2x minus 3 with negative sign. So minus 2x minus minus plus 3. Minus 2x minus minus plus 3. This minus 2x and plus 2x get cancelled. Here 3 plus 3, that is 6. So denominator is 6. So we take that 6 common outside the integral. It is constant. So I is equal to 1 upon 6 into integration of 2x plus 3. This 2x plus 3 to the power 1 half. Square root means power 1 half. Plus here 2x minus 3 to the power 1 half and dx. Now separate the integration. So this is equal to I is equal to 1 upon 6 into integration of 2x plus 3 to the power 1 half dx plus this 1 upon 6 into integration of 2x minus 3 to the power 1 half dx, and integration from 3 to 5. Here integration from 3 to 5. 3 to 5. Here also 3 to 5. So we use here formula integration of x to the power n dx, that is equal to x to the power n plus 1 upon n plus 1. So I is equal to 1 upon 6 x to the power n. So twice x plus 3 to the power n plus 1, 1 half plus 1, that is 3 by 2 divided by 3 by 2. Here in place of x there is 2x plus 3. So take the derivative of 2x plus 3. It is 2. So divide by this by 2 means right here 1 half, and integration from 3 to 5. Integration from 3 to 5. Here also this 1 by 6 as it is. Here use integration of x to the power n, that is x to the power n plus 1 divided by n plus 1. So 2x minus 3 to the power 1 half plus 1, that is 3 by 2 divided by same number 3 by 2, but in place of x there is bracket. Take the derivative of bracket. 2 into derivative of x is 1. Derivative of 3 is 0. So it is 2. So divide by 2 means right here 1 half. And integration from here 3 to 5. Get it? Now this constant and this constant take the outside the square bracket. And so here also take constant outside this square bracket. So here 1 upon 6 into this 1 upon 3 by 2 we write 2 upon 3. And here this 1 half, and here twice x plus 3, twice x plus 3. Now we put here in place of x 5, that is 2 into 5 plus 3, 2 into 5, 2 into 5 10, 10 plus 3 13. So 13 to the power 3 by 2. Get it? Then put the value of x as 3, 3 into 2 6, 6 plus 3 9. So minus 9 to the power 3 by 2. Firstly we take this constant outside the square bracket. This 1 by 6 as it is. This 3 by 2 we write 2 upon 3. This 1 half. And then we put value of x as 5 and then 3. Firstly put 5. So 2 into 5 10, 10 plus 3 13. So 13 to the power 3 by 2. Then put x as 3, 3 to the 6 plus 3, 9, 9 to the power 3 by 2, and take here minus sign. Here also take same procedure, that is 1 upon 6, this 3 by 2 we write 2 upon 3, and this 1 half, and in the square bracket, here put the value of x as 5, 2 5 is a 10, 10 minus 3, 10 minus 3 7, 7 to the power 3 by 2. Then put x as 3, 2 3 is a 6, 6 minus 3, that is 3, so 3 to the power 3 by 2. And now here this 2 and 2 get cancelled, here also 2 and 2 get cancelled, so it is 1 upon 1 into 1 into 1, 1 upon 6 into 3, that is 18. In the bracket, here 13 to the power 3 by 2, 13 to the power 3 by 2, see here, 13 to the power 3 by 2 we write 13 to the power 1 half to the power 3. 13 to the power 1 half means root of 13 to the power 3. Root of 13 and its third power means here root of 13 into root of 13 into root of 13. Root of 13 into root of 13, that is 13. So we get here 13 into it is equal to 13 into root of 13. Solution of this. So we write here 13 into root of 13. Now here 9 to the power 3 by 2. Firstly take the square root of 9. Square root of 9 and then third power. Square root of 9 is 3 and 3 to the power 3. 3 into 3 into 3. 3 3s are 9. 9 3s are 27. So it is minus 27. Here also 1 into 1 into 1. 1. 6 3s are 18 in the square bracket. Here we write using this method, here it is 7 into root of 7 and minus here also 3 into root of 3. Now here take 1 upon 18 common, here 1 upon 18, here 1 upon 18, so 1 upon 18 and in square bracket we write this 13 root of 13 then plus 7 this plus 7 root of 7 then this minus 3 root of 3 and this minus 27. This is the final solution. 1 2 3 4 terms, here also 4 terms, this 13 root 13, this 7 root 7, then minus 3 root 3 and then minus 27. This is the final solution. We highlight this solution like this. So this is the solution of the fifth problem. So we have completed here fifth problem. Now next problem, sixth problem, integration from 0 to 1. Sixth problem, integration from 0 to 1 x square minus 2 upon x square plus 1. X square minus 2 upon x square plus 1 dx. Firstly, we have to solve this integration using the previous methods. We have solved so many problems in chapter indefinite integration. Now here x square minus 2, here x square plus 1, here x square, here x square. So we adjust here plus 1 in the numerator. So firstly call this as I is equal to integration from 0 to 1 denominator x square plus 1 as it is. Here x square take plus 1, so plus 1, this minus 2 and cancel this minus 1, it become minus 3. So minus 2 minus 1, it is minus 3 dx. Now divide separately to x square plus 1 and minus 3. So we get here I is equal to integration from 0 to 1 x square plus 1 divided by x square plus 1 and minus 3 upon x square plus 1 dx. Now this x square plus 1 and x square plus 1 get cancelled. So here 1 remains. Take separate integration. So it is equal to integration from 0 to 1 dx minus this 3 constant. So 3 into integration 0 to 1 upon this x square plus 1 or 1 plus x square dx. Now it is the derivative of tan inverse of x, d by dx of tan inverse of x, 1 upon 1 plus x square. So both are standard formulas. So it is equal to integration of 1 is x and it is from 0 to 1 minus 3 as it is. Here integration of 1 upon x square plus 1, it is tan inverse x because it is the derivative of tan inverse x. So tan inverse x and from 0 to 1. So we get I is equal to x 0 to 1. So in place of x put 1 and then 0. So 1 minus 0, 1 minus 0. Then minus 3 in the bracket tan inverse of x. Firstly put x as 1 and then 0. That is tan inverse of 1 minus tan inverse of 0. So we get here 1 minus 0 means 1 minus 3 tan inverse of 1. 1 is the value for which angle? 45 degrees. So tan of 45 is 1. So tan inverse of 1 is 45 degree. We write in radian measure, that is pi by 4. So pi by 4 minus tan inverse of 0. 0 is the value for which angle? Tan of 0 is 0. So here tan inverse of 0 is 0. And so we get here I is equal to, final solution here, 1 minus 3 pi by 4. 1 minus 3 pi by 4. This is the final solution. So this is the solution of the fifth problem. Now here we have completed this sixth problem. Here this is sixth problem. So in this video lecture we completed sixth problem. In the next video lecture we will see the remaining problems. Today we stop here. Thank you.